Okay, yesterday the Drac plus Apollo, and now we're going to do GraphQL and Node. I actually wanted to do this first yesterday simply because I want to know what's happening behind the scenes before we do the front end. But it actually went well. We don't even need to know that much in the back end, we only need to know the schema. And that's probably what matters for the front end. Something that the back and front will actually agree upon. The schema. And yeah, let's just do GraphQL. It's enough with me yapping about. I've actually done the introduction already, but we're gonna go through it again. Project, yeah, seen this. GraphQL's Rising Star, yes. I've read this already. We're gonna do another clone of Hacker News, but now we're gonna do the backend. The next chapter. I don't even know if I'm recording. Okay, great. You'll set up GraphQL schema. Okay, that's great. Let's create a directory that holds the files for a GraphQL server. Okay, I'm gonna do it the desktop. Hacker News node. Okay, let's do the npm inits -y. Then, yes, of course, we'll go ahead and create. This will be called index.js. Source index.js. It really need to execute the memory. It's starting action, and it's still empty, of course. Let's go and start building up this printing. There's a surprise. Add a dependency. Surprise. GraphQL Yoga. It's a fully featured GraphQL server. It's based on Express and a few other libraries. Express, that's great. Web functionality subscriptions, TypeScript. Oh, okay, that's nice. Middlewares. Okay. Run server can be deployed now. Up native. Open up and type the following. Whoops. GraphQL server. Require GraphQL Yoga. Const type def SQL. Type query. Info string. Const resolvers query. This is the API of a Hacker News clone. Const server and new GraphQL server. I'm gonna pass in type defs. Okay. And the resolvers. Then we're gonna start server start. Console.log server is running on HTTPS localhost 4000. Okay. I think it's probably when the code is shown, then it's verifies also why the code is found. Let's type everything out. Of course, this is true. Everything drastically improves your learning experience. That is true. What's going on through the numbered comments? 1, 2, 3. Okay. The type defs constant defines your GraphQL schema. More about this in a bit. Here, it defines a query type with one field called info. This field is string null. Can never be null with exclamation. It's the actual implementation of GraphQL schema resolvers. Now notice how it's integral structure behind the type depths. Indeed, they are identical. Finally, the schema and resolvers are bundled and passed into the GraphQL server, which is imported from GraphQL Yoga. It's also examine how they should be resolved. Go ahead and test your GraphQL server. Node source index. Okay, good, we're running. Okay. We're going to navigate the URL. Clicking the schema on the right. Okay. This thing means auto-generate. Okay, that's nice. It's generated. Symbol of ghost. We have it in our. Let's go and send your first. Great. That's what we got. First GraphQL query. It's not really my first, but okay. Now remember when we talk about the definition of info strings. When resolved, we are in control of what the value for the field is. So what happens if we turn null instead of actually formatting string in the resolvent? Feel free to try it out. Yeah, we're still gonna do that. I wanna know what happens. Test results you need. Okay, I'm gonna start. No, don't spoil me. Don't spoil me. I need to know. Okay, gonna turn now. Of course, it's gonna. It's gonna turn now, Ralph. Of course. What happens here is that the underlying GraphQL reference so the term thumbs up. Your solvers adhere to the type definitions from GraphQL scheme. Put differently, it protects you from making stupid mistakes. Is in fact one of the core benefits of GraphQL in general. It's really great. And it forces the API actually behaves in the way that's promised by the schema definition. This way everyone has access to the GraphQL schema can always be not sure about the API operations. Turn the API. It's the GraphQL schema, so tell what. GraphQL is usually schema definition language, yeah. Just turn Java TypeScript. Okay. Type system also define structures. Special root types, square mutation description. Yeah, this was explained from the start. There types comes to Java and open the GraphQL first mutation. Root types. Special root. 3 special root types. Special instruction is called root field. Defines the available API operations. For example, consider the following GraphQL schema we used above. Okay. This guy. Single root field called info. When sending queries mutation. So in this case we only have one root source and one possible where it's accepted by the API. Am I supposed to copy this? Okay, maybe it's just an example. Where users, an array of users. I think we have two mutation users. Wait, what? 3 root fields. User on query. Ah, okay. As well as create user on the mutation. Okay. How about this? We have ID and name for type user. Type is required because otherwise the schema definition will be incomplete. Yes. Well, we know that each API version always needs to start with a root field. However, we haven't learned yet what it looks like when the type of root fields another object type. This is the case where the types of the root fields are user in the info string, which is a scalar type. Okay. Scalar types. Okay, so scalar types probably be some kind of native types. Type of there's a definition for your application schema. Solvers represented by function of the same name. That gets passed through the resolver chain and every resolver can it from. Okay. When the type of root field is an object type, you can further expand the query. Okay. Selection set. It's the above schema. Mutation. We always query ID and name and of the returned user. We could potentially omit either of them, however. Oh, okay. At least one of its fields in the selection set. For the fields, it doesn't matter whether the type of the field is required or in the list. Type modifiers. For the user field, the return means it returns a list, which still cannot be null, of user elements. So this can also contain elements that are not null. Or can either receive an empty list. Is empty list null? No, it's not. For the user ID field, the return value could be null or a user object. Okay. Turns to users. The Prisma instance will get full access to your database service and can be used to resolve incoming requests later on. Whew! Now theory. Angry face, let's go and write some data. What role do the root fields play for GraphQL API? The root fields are root types. Root fields and it's another term for us. No. They find the available API. Wait. This seems similar. I'm pretty sure they just define it. Okay, great. In this section, you're going to implement the first API operation that provides the functionality for a hack. Bring a feed of links that were posted. I don't even know if I'm recording. Okay. Let's start by implementing a feed query which allows you to receive a extend the GraphQL schema with a new root field, new data types if needed. Schema driven or schema first development. Wait, I'm gonna read this again. By implementing a feed query which will allow you to retrieve a list of linked elements. Extend the GraphQL schema definition with new root field, new data types needed. Okay. Okay, let's go ahead and tackle the first step. Extend the GraphQL schema definition. You need to update the type depths to look as follows. String. Defining a new link. Type that represents the links that can be posted to Hacker News. The description URL. List of link elements. Okay, cannot be known. In fact, one thing we haven't mentioned yet is that not only root fields, but virtually all fields on the types in figure have resolver functions. So you'll add the resolvers for the ID description, your fields, the link tab as well. Resolvers. Okay. Where should I put this? We have above the resolvers. URL HowToGraphQL.com. Description full stack tutorial for GraphQL. Info. Actually, let's turn this back. Feeds. Links. Then link. Wait, what? links. Oh, it's inside their solvers. Parent. Stored in memory rather than being persisted. Yeah, memory. Adding your solver for the feed will fill down so the solver also. After it's gonna fill from the schema definition. Yeah. And observe the responses from sent by the server. Lol. Okay. Wait, what? URL is lol as well. What the hell? That's weird. How to GraphQL. Oh crap! I put description here. That's why. Okay. How to GraphQL full stack to GraphQL. Lol. Consider again the query from above. Feed URL description can also be found inside the schema definition. Now you also learned that every field inside is backed by one resolver functions. Yeah. Yeah, this guy here. Did we even touch this? What if I change this to full ID? Okay. Previous resolver execution. 4 arguments with the remaining turn out in scenario. Now we're simply mocking them. Don't worry, you'll get to know them soon. Parent, or sometimes it's the result of the previous resolver execution. Parent. GraphQL requires can be nested. Each level nesting one resolver. GraphQL query therefore has to execution of feed. The GraphQL server is smart enough to invoke the resolvers of the link type. Because thanks to the schema, it knows that feed returns a list of link elements for each element inside the list so returned to the previous resolver. Therefore, in every of 3 link resolvers, the incoming parent and object is inside the links. I'm gonna read this again. Smart enough to invoke resolvers of the link type. Okay. Smart enough to know this. It knows that if it returns a list of link elements for each element inside the list that was returned on the previous resolver level. Therefore, in every of the 3 linked resolvers, the incoming parent object is the element inside of this. Okay. Because the implementation of the link resolver is trivial, you can actually omit them and their server will work in the same way as it did before. Alright, let's see what happens. Let's do that. So I'm gonna guess it gives me the link 0 now. Okay. It's the same. So okay, we're gonna get onto that. How are GraphQL queries just solved? Schema by invoking all resolve. Okay. By invoking the resolve of the root field. By invoking the resolver functions for the fields contained in the query. This guy. Okay. I'm not recording, am I? Okay, great. In this section, you'll learn how to add mutation GraphQL. Mutation will allow you to post new links to the server. Okay, great. We're gonna do the mutation now. Operation to GraphQL schema definition. Type def string as follows. Then it returns link. URL string, description string. The schema is already has grown to be quite large. Just refactor app a bit, then pull the schema out of its own file. Guess I'm gonna delete that. Lives in its own file. Source schema.graphql. One convenient thing about the constructor of the GraphQL server is that type defs can be provided either direct as a string. To look as follows. Then mutation post parent int args const link id no okay. Mutation. This is definitely mutation, mutating the links. earlier. Also, here's what's going on with the numbered comments. You're adding a new integer value. Yes. Then adds the existing link and finally returns the new link. Send our past 3 args. Of course, arguments. There's arguments. In this case, the URL and description of the link to be created. Yes. We don't need it for the feed and info resolvers before. Because I was wondering what fields don't specify an argument schema definition. Here's a sample mutation you can send to the playground. Okay, we're gonna do the mutation and then post, and then we're gonna give it an argument of dot what do I want to do again? Developer.net description. What's the description color different? Okay, this just need to be double quotes. Okay, apparently. A tutorial site and a news site, a news and forum site, and then we're gonna get back the ID. Good, that's great, that's great. And now, yeah, let's verify that. Okay, I'm gonna add more. I'm gonna say YouTube. Watch videos online. Link to. Maybe a last one. Let's say. Let's just do this. Prisma.io. Yeah, let's do the feed from earlier. Let's actually post. Query feed. Okay, they're working. Okay, that's great. However, once you kill resource 7, no, yeah, of course they're gone. They're in memory, of course, like stored in memory. And the links, they're not yet in the database. So learn how to add database to the GraphQL server in order to process the database on the runtime of the server. Oh god, that's screaming in the background. So if you want to practice implementing GraphQL servers a bit more, it's an actual challenge for you. Okay, based on your current implementation, extend the GraphQL with full CRUD functionality for the link type. In particular, implement the queries and mutation that have the following definitions. Okay. Optional challenge. No, that's not optional. I'm gonna do that. Me, that's not optional. I wanna do the challenge. Okay. Am I supposed to do link here? ID, and then we're gonna return link, which can be null. Okay. Update link. ID, URL string, and description string returns link, and also delete link. Let's do the link first. ID. Okay, so can I do this? Can I do that as well? We're gonna search for the link in the links. So let's say const link equals links that find item.id is equals to link. No, args, not link. No, args.id. Yeah. Actually, we're going to return that. Is this going to return an array or? Let's just try this first. Let's go to the feed and then let's grab this ID. Wait, what? There we go. Link. Let's get its ID, description, and URL, and pass in ID and give that link 0 ID. I hope we get this. Pretty sure it would work. Yeah, there we go. What if I remove the ID? I only get description URL. Okay, great. Holy crap, I'm getting it. Okay. Now let's do the update link and delete link. Mutation, let's go. Update link. And let's parent and args. Fine. And then this guys can be null. So what if I did link that URL and set it to args and then URL, but it doesn't. It's null. Let's see. Let's just see what happens. Args description. URL. Cool. Oh crap. Wait, is this correct? No, it shouldn't be here. URL. Find is not defined. Okay. Links at find. Update link. Okay, x.com. But what if I didn't? I entered nothing. Okay, no. Okay, what if I do? I don't know. Google.com. What if I then let's get speed from that. Actually, it's okay. Oh, cannot return null. So if I do update that, then URL. Why does it say still? Why still no? description. Oh, of course I didn't. The description and null because the method we just. Okay, what we're gonna do is let's do that. So if it's null, it's just gonna return itself. So yes. If I change URL to will.com, get that, and if we get this, great, that worked. Okay, let's do the delete. Now this one's gonna be easy. Link can be, and I don't know. Index links that index of link one return link. Okay, it can return null. Link can be null. So this will throw an error if save link. Oh shit. Alright. Feed. And what if I delete link and the first URL only? Okay, then if the feedback got empty, should get empty. Did not delete it. Did it? Delete link. Slice is slice this. It mutates the array, or it doesn't. It did not delete the link. Is my ID wrong? Let's do ID 1. Prisma IO. Okay. Links index of link 1. Item.id args.id. That's weird. It actually found the link. See? 0 would be the first one, HowToGraphQL. Links that slice. Then if we query for it, then it shouldn't be in here anymore. It should be splice. Oh my god. Let's try again. I'm pretty sure this would work right now. Let's give it 1, so there's 2 of them, and then let's remove the first one, 0. Boom, gotcha. Gotcha, baby. Okay, let's move on. It's working. Challenge accepted and challenge done. Argument that's passed into the GraphQL resolvers. What's the second argument that's passed into the GraphQL resolvers used for this? It's the args. It cares the return value of the previous resolver. It cares the arguments for incoming. It's an object that all resolvers can write and read from. It's quite similar answers. It cares the return value of the previous. No. I'm pretty sure this one's pretty obvious. Okay. It took me quite a while, but whatever. Kinda had the brain fart. Okay. In this section, you're going to set up Prisma along with the connected database to GraphQL. By now, you already understand the basic mechanics of GraphQL servers work under the hood. Surprisingly simple, right? Start with the graph. The second actual follow servers. Server. So, what's then the difficulty in building GraphQL servers? So it can become extremely complex. Multiple levels. Tip. Authentication, authorization, pagination, filtering. Should have. Not very compelling. Access the database directly. Should know ORM. Or which may similar before the server falls short as well. Prisma solves problem by providing a convenient data access so it's taking care of solving Prisma. Client API server Prisma client. Prisma server then the database. The Prisma server provides the data access layer and you're making it easy for the API server to talk to the database through Prisma. In essence, Prisma lets you easily connect the GraphQL solvers in your API server with your database. Okay. Connect GraphQL resolvers in your API server with your database. Okay. You're going to build everything from scratch. For your Prisma account, you're going to start with the most minimal setup as possible. Prisma. Okay, we're gonna create a Prisma directory. Make their Prisma and then touch Prisma .yml. Touch Prisma data model of Prisma. Main configuration for your Prisma setup is on the other end contains the definitions of your data model. The Prisma data model defines your application model. Each model will be mapped to a table in the underlying database. So far, the data model for your Hacker News app only contains one type link because Prisma uses GraphQL STL for basically copy the existing definition from schema. Adding the @id directive to the IT field. This means both generate and store global unique IDs for the link records. Created at datetime at created at. Okay. Okay, directives. This directives @signed. Managed by Prisma and will read only in the API. Stores the time for when a specific link was created. You can also annotate the field with updated at. Create direct. Oh. What is this? The HTTP endpoint for your Prisma API points to the model file, which is the foundation of the Prisma client API that you'll use in the API server. Okay. Generate in which language the Prisma should be generated and where it will be located. JavaScript client, source generated Prisma client. Okay. I think I've installed this already, but we're gonna do it again. I did it just yesterday with the front end tutorial. Note that for this tutorial, you'll also free demo. Yeah, just like yesterday. Now run Prisma deploy. Yeah, I think I've already had it set up. You can deploy it with Docker, the cloud provider of your choice. Bad indentation? I have no idea. Same thing. Okay, there we go. Use an existing database. We're gonna use the demo server we had from yesterday. Or is this a new one? It's gonna be a new one, I think. Yeah, we're setting up another different service name, so I guess it's a new one. Here's sample code that you could use in any simple Node script. Generated Prisma client main create link. Am I supposed to do this as well, or is this another example? Okay, it doesn't tell me to copy it, so thus great details and stuff. In the next chapters, you will evolve the API of your server and use the Prisma client to access the database inside your resolver function. Why is the second GraphQL API defined by the needed in GraphQL server architecture with Prisma? By the application schema needed in a GraphQL server architecture with Prisma. Wait, confusing. Why is the second GraphQL API defined by the application schema needed in a GraphQL server architecture? It's Prisma. No. That's weird. Not sure about this, but The Prisma API oops, today, but doesn't allow any sort of like the next chapter. You're going to connect your GraphQL server with Prisma API, which provides the interface to your database. This connection is implemented by Prisma client. We're going to start this section with a bit of a cleanup and refactoring. Remove the links array. So we're going to use an actual database, of course. So sorry if you're hearing those noise in the background. How about this, guys? You're not gonna tell me how to do this other stuff with Prisma. Root args, context, and info. Just for oh, these are the 4 arguments that was said earlier. How am I gonna update this using this context Prisma? I don't have a context, man. Third one is needed. All GraphQL servers always have 4 arguments. Now I remember that. Plain JavaScript that every resolver in the resolver chain can read from and write to. It thus basically means for resolvers to communicate. As you'll see in a bit, it's also possible to already write to it the moment when the GraphQL server itself is being initialized. Wow, that's always a bit faster. Prisma client instantly context. More about that soon. Prisma object on context. As you will see in a bit, this Prisma object actually is a Prisma client instance supported from the generated Prisma client library. We haven't done that, have we? The Prisma interface lets you access your database through Prisma API. You can post resolver. Root args. You can pass in the context. Create Prisma link. Similar to the previous invoking Prisma client. The context. Ooh. When did we attach this Prisma client into the context? We just created the Prisma stuff generated. You're sending the create link method from the Prisma client API. As arguments, you're passing the data the resolvers receive via the args parameter. So to summarize, Prisma client exposes your CRUD API for the models in your model for you to read and write in your database. Smart methods are auto-generated based on your model in the definition. Data model Prisma based on this. Okay, so this method is auto-generated static. Okay, and it's based on the data model Prisma. Okay, access automatic and often mentioned Prisma client instance. It's a context. Add a new dependency to your project. JavaScript, am I right? It's required to make the auto-generated Prisma client work. So now you can attach generate to the so that your solvers can get access to it. Import Prisma. Attach it to the context. GraphQL server. The context object that's passed into all your GraphQL server is being initialized right here because you're attaching the Prisma client to it. When the GraphQL server is instantiated, you can access context Prisma in your resolvers. Oh, that's great. Okay, so we can access Prisma from the context always. Resting the new with this. Please don't give me an error. Okay, great. No error. But now it's empty because we're accessing the database and we don't have anything in it yet. Okay, let's try. We don't have a post yet, do we? We have create link. I mean, we do have post. Oh my god, I'm stupid. Post and create. What I meant is the update and delete link. We don't have that. So I'm gonna try this. Oh my god. Post ID. Let's give it a try. And okay. Okay, that's weird. Then it's context prisma.links. Create link URL args description. So let's view that. What is the main responsibility of Prisma binding instance that's attached to the context? Well, you know, expose application game at the client. No. No. Okay. Wala na. This second and third options look similar. My god. Bilisan nyo, huwag kayong maingay. Huwag maingay. No, I'm lost. Translate the GraphQL operations from the Prisma API into JavaScript functions. Ano ba? Ano ito yung isa? Oh fuck, it's this one. Sign up and login functionality that allows the users to authenticate against your GraphQL server. The first thing you need to do is a way to represent your student database. You're gonna achieve by using it. By users. Oh, second. Made a mistake, I got distracted. Current contents of the following. So we're gonna remove created at. Unique. The user then has a links field that's a list of links. This is how to express a one-to-many relationship using SDL. After every change you're making to the data model, you need to redeploy the Prisma API to apply. Oh my gosh, I'm going to deploy and generate every time. One-to-many relationship. So it's because we're using user and then user we use also using link, so it can explode or something. Just now updated the Prisma API. Right now, it's a bit annoying that you need to explicitly run Prisma generate. Yeah, every time you're migrating. Great. Add the following lines to the Prisma YML. The Prisma client will not automatically generate upon change. Okay. Remember the process of schema-driven development. It all starts with extending your schema definition with the new operations that you want to add to the API. In this case, a sign up and a login. Source schema. Update the mutation as follows. Okay, so I'm going to remove this from the challenge. auth payload, then login string. Next, go ahead and add the auth payload along with the user. Yeah, we're gonna define that. We have a token, so yeah, we're really doing some. We're gonna do some authentication. Type user is ID, name string, email string. The sign up and login mutation be very similar. Sign up, login, email string, password, name. They both return a auth payload, which can be used to authenticate subsequent requests against your bundled in the API payload. Finally, you need to reflect that the relation between user and link should be bidirectional by adding the posted by field to the existing link model definition schema. Implementing the resolver functions. After extending schema definition with a new print, you need to implement resolver functions for them. Before doing so, let's actually refactor some your code a bit further, more modular. Okay, so they're gonna go into their own paths. Then query.js. And also have mutation.js, user.js, and link.js. Next, move the implementation of the feeds. So it's this guy. Okay. I don't want function. Parent args context info. Context Prisma links. Then module exports feed. This is pretty straightforward. You're just re-implementing the same functional from before with a dedicated function. Next. It's a lot. Const sign up async parent args context info. Wow, big rip, that's nice. Salty 10. Context.prisma create user args and password. Going to store the hash there. Ooh, JWT. Sign user ID. Context at prisma.user. Okay, then email args email. It's like from MongoDB mongoose. So it's kind of probably searching if the user exists. See, on the second one, thus throw new error, no such user found. Const valid equals await. Bcrypt. Compare arg. Oops. If valid, not valid, then throw new error. Invalid password. Args user password. Okay. So if this guy exists, then we're gonna bcrypt the past and password and the user password, so their hash compares. Then great. User ID, and then pass in the app secret, although we don't have that yet. What post? I don't have post in here, so I'm gonna grab index post. Oh, you'll add the post resolver in a bit. Starting with sign up. Encrypting user accounts is bigger. Yes. Yes. So sending J double T. Since the token and the user. To adhere to ship the auth payload. Yeah. String and user. Okay, that's great. The next step is going to provide the one certain password. Yeah, and then you think, yeah. So creating user, and you're now using retrieve existing user record by email address that was sent along the argument. Okay, that's great. npm I JSON web token bcrypt.js. Played with those two before. Next, you'll create a few utilities that are being used in the utils.js. Sekretong malupit. Const get user ID context, then const authorization context request authorization. Prisma is definitely giving us a lot of this API. If authorization, then const token authorization replace bearer that const user ID app secret return user ID. So if that didn't happen, then we're going to throw an error, not authenticated. Okay. Verify request get authorization. So token Okay. Token authorization that replace bearer. Okay, so we deleted bearer. Should be in space there. Still call in resolvers. Oh, okay. First is strip the process header from which contains the user's JWT from the context. It then verifies the JWT and retrieves the user's ID from it. Notice that if the process is not successful for any reason, the function will throw an error. You can therefore use it to protect the resolvers which require authentication. To make everything work, be sure to add the following imports to the application.js. Oh my god. However, when initializing context, you're only attaching the Prisma client instance to it. There's no request. Index. Okay. There's no request object, so yeah, it's only Prisma. Return. Instead of attaching an object directly, you're now creating the context as a function which returns the context. Okay, that's great. To read the authorization header and validate if the user was submitted the request eligible to perform. Yes, that's pretty clever. This request. Schema resolver setup. Right now, post still missing. Yeah, it's still missing. This one is an async. Posted by connect ID user ID. What if I just you're now using the get user ID. Yeah. Oh shit. Before it's invoked, so maybe we do need to separate that. So this doesn't get called. The fuck? who's not authenticated. We're then also using the user ID to connect the link to be created with the user who is creating it. This is happening to the nested object posted by ID user ID. Connect. Okay. Okay. There's one more thing you did before I can launch. Scalar values from. Yeah. However, we're now adding two fields here. Cannot be resolved in the same way. Posted by on link and links on user. This field needs to be explicitly. You're first fetching the link using the Prisma, and then invoke posted by on it. That's the solver needs to be called posted because it resolves the posted by field from the link. Type in schema.graphql. Yeah. Open users.js const links parent args context Prisma. Parent ID user.links user links. Then we're gonna module.exports links. Last thing to do now is to use the new resolver index.js. To look like this. Okay. Query mutation user link. We need to test authentication flow. Okay. I hope there's no error. Okay, that's great. Then we're passing in name Alice, then email oh shit, I'm not done. I'm gonna get token and user ID. GraphQL. Whoa, that's pretty fine. Data cannot be. Got an error. Email. Data cannot be non-input type. User create input mutation. Okay, what did I do wrong? bcrypt at hash 10. Await context at Prisma. Create user args. Password. Sign user ID. User app secret. That's weird. Let's rerun. Sign up null. Give me null? Could be a problem with the. I don't know. Let's see if this works. Holy shit. So there's something more. Mutation user link. Hash create user and sign. These are all from. Does it have something to do with this? We're doing the sign up. Variable data cannot be non-input type. 2, 3. Context. This is the second what I did earlier. Okay, this is weird. Whoa. Could it be the schema? I have a problem with schema. I want to find this out. Did I miss something? Let's check this one by one. Okay. Link user. Maybe we have a problem with this one. Holy shit. Resolvers. I got an error. Data user create input cannot be input type. This could be a problem with the schema. Well, it's the same. Let's see. Maybe I didn't do this? Oh, maybe I didn't really generate. Maybe I didn't generate. Okay, now this one. Then, did it generate? It's just... Okay, I'll be back. I'm just gonna go take a look. Maybe the schema from this guy. It's the same. Let's just redo. Posted by user. Then the resolvers. Let's try to remove our ES6 functions, arrow functions. See one by one. Don't have the post yet. This could be the problem as well, but I don't think it's this. Where's our post? There we go. This could be something more if this doesn't work. Holy shit, what is this problem? It's the same, my code's the same now. Oh my gosh, this is going to make me cry. Let's go back. We were able to post. Not authenticated, of course. So that works, but we can't sign up. What the hell? Oh my gosh, what is this? Let's clear our Prisma database. Hacker News Node. Oh my god, let's go. Let's delete Hacker News Node at dev. Let's remove this one as well. Server at dev. Okay, now we don't have any server. Then we're gonna go Prisma deploy. What did I miss? Run Prisma deploy and generate node source index. Feed, we got nothing, of course. Sign up. Whoa, that's crazy. It wasn't my error. There's something in the Prisma Cloud stuff. Oh my god. Okay. I'm gonna revert back. I don't want to use this. I want to use 6 arrow functions. Let's see if this will still work. I'm pretty sure this will still work. Whoa, the frick? Okay, sign up. And then also okay. This should be good. Now we're gonna go again. Let's say Chris. No, I don't want Chris, I want Ian. Ian at email.com. Ian. Okay. Copy the authentic. Whoa, why is it changing? Weird. And then inside the new tab, open HTTP headers. Similar to what you did in Prisma Playground before. Authorization. Bearer. Send requirement. Okay, let's post. Let's do the post. Okay, this would be good. Not authenticated. It's because it's in here. It's in the new tab. Let's copy this. There we go. There we go. Yeah, nice. Got the ID back. Then, when your server receives invitation, it invokes the post resolver and therefore validates the provided JW. Additionally, the new link was created and made. To verify everything worked, and send the following login mutation. Login. Email. Ian at email.com. And then password is Ian. Wait, what? Unknown argument. Oof. There we go. Why was the user type redefined the application schema when it's already part of the Prisma database schema? Can never be imported, no? Wide potential. No. No. In this section, you'll learn how you can bring real-time functionality into your app by implementing GraphQL subscriptions. We can also implement those. Okay, real-time. Let's do some real-time stuff. New link elements created and existing. Anyway, the tool setting this. I'm using the old one. Yeah, I want to use the old one. I don't want to use that old thing. Okay. WebSockets. Played with Socket.io before. Yeah. Say only whenever some event it is interested in. It's very aware of the first event. Out of box. Let's subscribe to the following events. A new model is created, an existing model is updated, existing deleted. Great, okay. This events. Subscribing to new link elements. An effort. First step, someone is trying to extend your GraphQL schema definitions. Okay, what are we gonna add? We're gonna add type subscription. Oh, this one's special with type. Subscription. New link. Next, go ahead and implement the resolver for the new link fields. Resolvers for subscriptions are slightly different than the ones for person mutations. They return async iterator, which subsequently is used by the GraphQL server to push the event data to the client. Are wrapped inside an object and it will be provided as the value of subscribe field. You also need to provide another field called resolve. Money sign. Subscribe link mutation that underscore in. So this how you subscribe that node. Const new link. Yes. Subscribe new link. Subscribe resolve payload. Payload. Okay. This code seems pretty straightforward. As mentioned before, the resolvers provide us the value for a subscribe field inside a plain JavaScript object. As mentioned before, want to make this one line. Okay. Context expose subscribe property, which processes the subscription from the so use the resolve in pursuant. Open index.js and add an import statement from subscription. Subscription. Resolver subscription. Then update the definition of the. Why is it in the third? Does it matter? Testing the subscriptions. With all the code in place, it's time. Let's make 2 instances of it. Okay. That's I'm gonna feed first. Get the feed. Okay, and then no, not copy that. link ID URL description posted by ID name URL. Oh, URL email. Okay, we're gonna listening. Okay, it's listening. We're not gonna see the results yet unless we post something. Send the following post. Oh, wait. Oh my god, no. Listening. What did I do? What happened? Did I press it? Or should it be in a different... Okay. Maybe I should do it in a different tab. Okay, let's see. There, null. I got null. Not authenticated. Okay, headers. Now this one has authentication, doesn't it? It doesn't have. Did I close that? Oh my gosh, let's get my account. How do we get my account again? I did that earlier. Oh, force the login. Can I just get a token? Yeah, of course. What's this about? Then we're gonna authorization. So we're listening here, then we're gonna post. It's no valid token. What? Better that we're gonna post refresh. Let's just sign up. Oh my god, this one's already login. Where's my login? That's weird. Prisma.io. Why didn't the authentication work? Could be something to do with my utils. Could there be something wrong with this? I was able to log in though. Good. Let's see. Post mutations. Get user ID context. Args URL description. Description. With this. Let's see. Oh, this is invalid. You know what? Let's just create a new one. Although we created that. Let's go, John. There's your token. Let's subscribe. Subscribe. Let's post first. Okay, we were able to post. And we'll do the subscription. Alright, it's listening, and then we're gonna paste, and we're gonna say, no, I don't want Google. Let's go, I don't know, Twitter. Boom! Live subscription. Send a following post. Yeah, did that. Okay, that's great. Implementing a vote mutation. The next feature to be added is a voting feature which is used. Sorry about the barking dog in the background. Prisma model. Vote. And we're gonna define that vote. Vote. Type vote. ID. Generated by Prisma. Directive stuff. User. Is this correct? So we're gonna deploy again, right? Code script operation for the new vote type. Yeah. One-to-many relationship. Yes, thanks to our hook. Thank you, hook. And for mutations, we're gonna create vote. Link ID returns vote. We're going to define vote bottom. ID link for user. For all the votes from link, so you need to adjust the link. Yeah, of course. Context Prisma exists vote. ID, then if link exists, then throw new error already voted for link argset link ID. Then if not, return context Prisma create vote. Then for user connect ID user ID. Connect. Oh my god. Wait, what? Why does this have an error? Similar to what you're doing in the past as well. The first step is to validate income data out with the get user ID to help. Okay, of course. Validate the JDD. The Prisma exists vote. All is new for you. Indeed it is. Exists. Pretty much check that exists. Text filter that allows to specify certain conditions about elements of that type. At least one of the elements of the database. That's true. So user, it's not yet voted for the link that's identified by args by link ID. At least one element. So wouldn't this always exist? Oh, so this exists then. Vote, of course. Okay, so then if it exists, then it's gonna return false because we already have the guy upvoting the link. Votes and link, user and vote and link and vote. Open link.js, of course. So do some const votes. Parents, args, and context. link. Wait, let's just see what's happening a bit. Okay. Where was I? Okay, I was here. Link, and then where they exported it. And then the vote type, of course. So we're gonna create a vote.js for its own solver. Fonts link. In index, I suppose. Of course. Subscribe. Before that, no. New vote subscribe. Current arts, context, and info. Context of Prisma. Hashtag subscribe. Dot vote. Mutation. We're in. Created as well. Node. New vote subscribe, and also resolve payload. Also don't forget new vote. Then of course finally okay, that's great. Prisma, yeah, they were exported. Okay. Let's try it, let's try it. So this one is the authorization, so we're gonna go for the subscriber for this guy. New vote. ID link, and within the link we have URL, description, name, and let's get an email. Subscribe. Whoa, no, it's not a function. Vote. No, subscription. Oh my god, I made a mistake. Okay, we're now listening. Then let's mutate. So let's go feed. Then we're gonna upvote. Let's upvote the second one. Just grab its ID. And then since we're already doing that, so mutation, let's go vote. And the link ID would be this. And then link, I'm gonna go grab back the URL, description, whatever. Let's go grab the user as well. We did that, so I made invalid token. Oh crap. Why do we have an invalid token again? Holy shit. Maybe it's not even saving the server. Let's see. User. It shouldn't be here. Of course. Should I delete it? Still very weird. Let's refresh this. I'm having this. Let's redeploy. Okay, whatever. Mark's password. Should be correct. Await bcrypt hash and context Prisma create user password. Sign user ID user.id app secret. Yeah. Okay, let's first let's sign up. John, let's go. Then we'll grab the token. We don't have anything yet. So we're gonna post. And we have our authorization using John. Authorization. Oh fuck, I know why. Misspelling, classic. Fucking classic. Should work. Okay. Then let's grab the ID. Now we should have one. Then let's vote. Let's use this ID. And we're authorized to John. Invalid signature. Okay, that's a different signature, so vote. Doesn't seem different. Okay. Okay, now that we have upvoted that, we can't go upvoting it again. Yes, already upvoted. Now I didn't try the subscription, so we're gonna subscribe again. We're listening, and then we're gonna create another post. Say google.com. Okay, an epic search engine. Post. We have that. We have the ID. And then for the vote, we're gonna give this guy the ID, and then when I click this guy, the subscription lab should capture it. Great. So we can capture the new vote and new link. We can subscribe to those. Okay, that's great. Let's move on. Which of the following statements is true? It's this one. We have WebSockets. This was clearly okay. Yes. Oh, this is the last section already, where you'll implement the finishing touches of your API. Just a sec. Oh my god, I can't see. Okay. Filtering, pagination, and sorting. You'll be able to implement filtering capabilities without major. Similar to the previous chapters, the heavy lifting of the cursor will be performed by the power of Prisma and lead to this forward-coming queries to it. The first step is to think about the filters you want to expose to your API. In your case, the feed query in your API will accept filter string. Query in you will accept. Okay. Okay. Let's give this guy first feeds. Let's give us a filter which will accept string. Okay, then next we need to update the implementation of the feed resolver. Mutation. No, not mutation, query. This guy. Holy crap, it's a lot. Const var args filter. Okay, so it has filter then, or description contains args.filter URL content. So this is probably some Prisma stuff. They handle this. And then if there isn't, then you're gonna turn nothing. Const links was await context of Prisma links where Okay, if no filter seem provided, then we're gonna get this empty object. Then probably where is work, I guess. So if it's nothing, then there's no filter. No filtering will happen. Any of this. Okay. So we have feed. Up to this. Let's add some more. Post. Is this my ID? My authorization's not here. What is John's? John. Let's grab that and then let's post another one. Let's say okay. Then we should have 3 of this. Then now we're gonna filter. Filter. I want you, so we're gonna get YouTube. Okay, so this one has a U as well apparently. Created GraphQL account to your email. Okay. Let's just say YouTube. So only YouTube. It's working. Pagination. Okay. Pagination. Guard how it can be tackled. Limp offset requires specific chunk of this by providing the start index offset as well as item subtrib limit. Cursor based system one is a bit more advanced. Every element in the list is associated with a unique ID. Then provide the cursor of the starting element as well as the count of the items to be retrieved. Prisma supports pagination approach. Yes. We're gonna go with the limit offset pagination. Okay. Limit and offset are called different in the Prisma API. Limit is called first, meaning you're grabbing the first X elements after a provided start index. Note that you also class are the start index is called skip since you're skipping the main elements. The list before skip is not provided by default 0. When you then all starts from the beginning of the list. So I go ahead and add skip and then to our solvers we're gonna add that fonts links were and then skip args at skip and then first args at first. Carried by the incoming args object. Yeah, Prisma will do the hard work for us for the skipping first. You can now test the pagination API with the following returns. Let's restart. Feed. Let's skip. Let's first not add any filter. Oh my god. Okay, now we're gonna add filter and we're gonna say actually not just first one and then skip one. So we're only gonna get first and skip one. So we should return google.com, right? Okay, we got an error. What do you mean skip? Yeah, I did say skip. First skip schema. Oh my god. We're gonna get Google. Epic. an epic search engine. And now we're going to do sorting. It's possible to return list of elements that are sorted or according to this specific criteria. Alphabetical by URL description. Put the client can decide how to order. New asserting in number press ordering options. GraphQL. Ascending, description, descending, URL ascending, URL descending, created at ascending, created at descending. Link consorted. Now adjust the feed query again. So we can add a order by link order. Okay. So it's similar to what you did in pagination. So it's order by args, order by. Turn links. Awesome. Here's a query that sorts. Let's start. First, let's not add any sort first. Then we're gonna grab created that. Okay, let's do that. Hey, why don't I have the order by? I didn't refresh it. There we go. Created at sending. Wait, what? Why am I having an error? Okay, so I probably had some spelling mistakes. Do what? No, I don't. So if I try this, why is that undefined? I clearly have it here. Let's say URL. URL works. Link. My gosh. It should be posted by. We're gonna see. It should be. Type link. Let's go back again. Pwede mamaya na. Hindi na ayos pa ako. Saglit lang. created at, but we have we are posted by. That's weird. That's really weird tutorial. We made it and created a here for the type of data model Prisma, but not in the actual schema model in the GraphQL we have here. That's not my error. See, even he doesn't have it posted by. Okay, let's just go. Let's just not use that. Well, right now we can actually sort by sending URL names. Returning total amount of link elements. The last thing you're going to element for is to how many links element are currently stored to do. So you're going to refactor feed type to be returned by your API feed. Adding the new feed, then also adjust the return feed. Okay. It's gonna be. Wait, what? Oh, okay, we're gonna turn. So, because some feed will have some array of links, I guess. Yeah, indeed. Yeah, we're gonna create links with an array of links, and then count hints. Now go ahead and go to the feed resolver again. Aggregate and count. Return links. Okay. You're first using the provided filtering ordering pagination to retrieve a number of link elements. Next, you're using link connection query from the number of top link elements currently stored in the database. The links encounter are then wrapped in an object to adhere to the feed type that you just added. Of course, the feed type, links and count. You can now test the revamped feed as follows. Let's see. Let's say query, then feed count links ID description. Wait, I have an error. Link. Why? Then should I pop it? Oh my god. I made an error with my schema. Link. Okay. You're out. Alright, that's great. Filter by. Alright, forgot. URL. What was my filter again? Holy crap. String. It contains cur. Which arguments are typically used to paginate through a list of limit offset pagination? Oh god, that's easy. Let's skip it first. Yes, it is indeed. It's not indeed. We're gonna skip the how many numbers and then we're gonna get the first how many numbers what's given. Summary. The next chapter. In this tutorial, learn how to build a GraphQL server from scratch. The stack used is based on NodeJS, GraphQL, Yoga, and Prisma. GraphQL is a fast, simple, and graphics framework built on top of ExpressJS. This comes with several features out of box, support for GraphQL Playground and real-time graph subscriptions. Solves your GraphQL server is implemented using this Prisma database. And they become part of the and there are features we can. Okay, I'm gonna give this guys a read. Stack. Prisma lock. I don't know about Slack. Find this tutorial again. Oh, tutorial fish. Yes, I learned something. Force. Next. Okay. Wow, got 97%. Congrats. 31 out of 31 chapters, got 97%. It's impressive. If you like the tutorial, I started on GitHub. It's really good. It's great having you. Next step, build something. Production. It's actually great. Should I give this a try again? Yeah, okay, let's give this thing a shot again. So we're gonna refresh this. I'm going to sign up. Let's say I'm gonna go for Danny or something. Danny. Prisma. Okay, so this is our token. And then what I want to do now, first I want to subscribe. Let's subscribe to new link. The ID was getting a description, URL, and posted by name, and maybe email, links as well, I guess. Oh my god, this is a lot. No, let's not add that. Let's just go. And then let's remove this. Okay, so let's listen for that. Okay, now we're listening for new links. And then we're gonna post. And we're gonna use this app. We're gonna use this token. Then let's post I don't know, GitHub. I don't even know githubs.com. Description. Epic open source site. Got authorization? Okay, so we got that. So if I remove the authorization, the token I mean, we won't be able to post another. Not authenticated. Great. And we got it listened. See? Subscription. And now we're going to, let's just go upvote. Let's vote. And vote would require link ID, which we just copy pasted. Just copy it and then let's get the ID. That's good. Where's that? Okay. Vote. Not authenticated. Let's just copy the authorization from the post. Oh my god, where's this authorization? It's gone. Should be in here. No. Scrap right here. And then Okay. Then we can not pose. Where's the upvote? Bearer. Okay, we should be able to do this. Okay. We were able to upvote, and then if I do this again, it won't be able because we've already voted. Great. Perfect. Let's see. Let's now do this. There should be a lot of them. And then okay, let's filter. Filter by, let's see what's unique in here. Say GitHub. What we saw earlier. Okay, we've got GitHub. And then let's see the skip thing, I mean. First, let's not do it so we know what we're gonna get. Let's say skip the first two and then grab the last two as well. So we should get only YouTube and GitHub, I think. Yeah, YouTube and GitHub. Great. It's working. Everything's working. Okay, that's great. Okay, I'm gonna continue studying this. I'm gonna read all this reference stuff all over here, but I won't be on camera anymore. Quit off the record. Okay, so yeah, we were able to learn Node plus GraphQL. Bye.